guys two sheets today. One is a cheat sheet, the front of it that has like a circle and a rectangle is for today. The back side of it is for section 1-8 on Thursday and Friday. So, and then you'll get the notes too. All right, one thing that I do have to just talk to you guys about, we had a department meeting this morning. And administration said that they heard that some classes are letting people take their phones 5 minutes early and they don't want us to do that. So the only way that you could take it a couple of minutes early is if you're taking pictures of the answers, okay? So they want it to be no tolerance and from bell to bell. So I just wanted to let you know that. So we are going to get started today. Today we're doing section 1-6 and that is on polygons. And a lot of what we learned today, I think you've learned before. So today shouldn't be too hard. So whenever you have a polygon, if they ask you if something is a polygon or not, it has to have straight edges. All of the edges have to meet. And what I mean by that is you couldn't have something that looks like this, where these two sides don't meet. That would not be a polygon. As I said, everything has to be straight. So if you had a curved side at all, that would not be a polygon. When you have a vertex or a polygon, they call where the sides intersect vertices, or a singular would be a vertex. And then you have all of your sides. So this would be like side GH, HJ, and so on. When you go to name a polygon, you can start at any point and you can go either counterclockwise or clockwise. So there's many, many different ways you can name this. You just start at a point and you'd either go clockwise or you could name it going counterclockwise. So I could say polygon F or GMLKJH or GHJKLM, any point, and you can go either direction. So this shows some polygons and then things that are not polygons. So notice here we have all straight edges. It's closed. There's no curved surfaces. In here, we have things that are not polygons. Now this one, it is closed, but this is actually two polygons. Because it's two triangles, that wouldn't be just a polygon. This one's not closed. This is curved. This has this random edge coming out, so that's not a polygon. This is curved and that's curved. So the next thing talks about the difference between convex and concave. And this may be something, do you guys still have that sheet of notes? Yeah, why don't you take that out? This might be something that you want to write in there. And actually, the more I think about it, I'll explain it to you. And then if you think you're going to write it down, go ahead. But basically, you can have a polygon that is convex or concave. And I'll just explain it to you first, and then you can see what you think about if you need to write it. So how the book explains the difference is for convex, they extend every side. Okay, so if you notice in pink here, they extended all of the sides. If when they extend the sides, you go in the inside of the polygon at all, that would be concave. Okay, you look at this one right here, they extended these sides, but when they went to extend this one, notice they went inside of the figure. That means it's concave. Now, another way to think of this would be, do you guys get that this kind of caves in? Like if it was a normal triangle, but now it's kind of caving in. If you think of, if something is kind of caving in one of the sides or multiple sides, then it's concave. I'll show you another example. You guys think this one's caving in? Right? Isn't this kind of caving in? So notice if I were to extend this side, notice I go inside of the figure. If I were to extend here, I go inside of the figure right here. But if that makes sense to you, that this is caving in, this is caving in, then you would have a concave figure, okay? Another example, it could even be just like this little bit that it caves in, and that still would be concave. Okay. Now, this I believe is on that sheet I just sent, the sheet I just gave you today. So I don't make you memorize these, although I think you probably know some of them. We all know 3 sides as a triangle. 4 sides is a quadrilateral. So don't think of 4 sides as being a square or a rectangle. The general term or the generic term for 4 sides is a quadrilateral. 5 sides, I think you all know, is a pentagon. 6 is a hexagon. 7, you may not know, is a heptagon. But you can use this sheet that I just gave you, the cheat sheet I just gave you on the test. So you could look at this. 8 sides, I think you all know, is an octagon. 9, you may not know, that one's a nonagon. 10, you probably know, is a decagon. And 11 and 12, I don't expect that you know, but an 11 side is a hendecagon and a 12-sided is a dodecagon. Now, anything above 12 sides in our class, how we name it is, if I said to you on a test, what is the name of a 22-sided figure? What you would do is you'd say 22 gone. Okay. If I said, what is the name of a 100-sided figure? It would be a 100 gone. Okay. Here's the deal though. if I said to you, what do they call an 11-sided figure? Because our book expects us to know these, you can't call it an 11-gon. You would have to give me the actual name. And like I said, you have this on your cheat sheet, so that shouldn't be a problem for you. The next thing that we're going to talk about is really what we want to know is regular, but to kind of lead to that, we have to first talk about what equilateral means. In this word, equa means equal, lateral means sides. So a polygon that is equilateral has all of its sides congruent. So equilateral would look like that. And it would have to have the same amount of dashes on all of the sides. Okay. Now, an equiangular polygon, equa means equal, and then angles. So what would happen there is in this figure, every one of the angles would have to have the same amount of arcs. If one of them had 2 arcs and the others had 1, that would not work. Then, if something is both equilateral and equiangular, it is regular. So a regular figure has every single angle marked the same, every single side marked the same. So one of the things we're going to have to say today is this regular or irregular? So like this right here, notice all 5 of the angles are marked congruent and all 5 of the sides are marked congruent. So that is a regular pentagon. Okay. An irregular polygon is one that is not regular. Okay, so it's something that is not regular. So if we go down here, they're asking us to name each polygon by the number of sides. So the first thing you're going to do is just count 1, 2, 3, 4, 5, 6. Do you guys remember what a 6-sided figure is? It's a hexagon. The second thing we have to do is say if it's convex or concave. What do you think? Concave because it kind of caves in. And then is it regular or irregular? What do you think? Irregular because these two have 2 arcs, 1, and this one has none. So the angles are not all the same, so it's irregular. Now let's go to B, and this one has 1, 2, 3, 4, 5, 6, 7, 8 sides. What's an 8-sided figure called? Octagon. Okay. Does this one cave in at all? No. So this would be convex. And octagons have 8 sides and 8 angles. Are all 8 sides and all 8 angles the same? Yes. So then it would be regular. Okay. For C, what is the generic term for a 4-sided figure? Quadrilateral. Good. Don't put rectangle there. You have to put the generic. Okay. Then this does not cave in at all. So then that means it's convex. And then the last thing is this regular or irregular. Okay, those angles are all the same. They're all right angles, but these 2 sides have 1 dash. These have 2, so they're not the same. So it's irregular. So all of the sides would have to have 1 dash, or all of the sides would have to have 2 dashes. Now, I'm quite certain D is on the test. Next week we'll have a test probably Wednesday. And part of this is a trick question. Okay. So first of all, this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So what is a 10-sided figure? Decagon. So does this one look like it caves in? Yeah. Okay. So this last one is where I think it's a trick question. When you guys look at this, for this to be regular, it has to have 10 sides that are congruent and 10 angles that are congruent. And if you notice, it has all of its sides marked congruent, so that's good. But with angles, do you see how it only has 1, 2, 3, 4, 5 that are congruent? There are angles right here, which you could either think of this angle or that angle, okay, that are not congruent to this. So it has an angle here, it has an angle here, it has an angle here, an angle here, and an angle here. So if something has 10 sides, it has to have 10 angles that are all congruent, and that doesn't. So it's irregular. Try to remember that because I'm like 99% sure that exact question is on your test next week. If we look at this one, it has 1, 2, 3, 4, 5, 6 sides. So that is a hexagon. And then would this be convex or concave? Doesn't cave in at all, so it's convex. And does that look like regular or irregular? Regular. It would be all of the sides are congruent, all of the angles are congruent. So now if we go here, I think you guys know perimeter is just the distance around. So if you were finding the perimeter of our room, we would just kind of go around the black floorboard here and we'd measure it. Circumference is what they call perimeter of a circle, and you guys know that. Circumference of a circle is the distance around, okay? Area is how much surface area that you need to cover it. So if we were doing the area of this room, that would be the flat part, like if we were to carpet it, okay? So here are formulas that we're going to use on the next page to be able to do this. So one of the things they're going to ask you to do today is find the circumference of a circle. That is the distance around, and it's either 2 pi times the radius or pi times the diameter. And when we do that in this class, we never use 3.14 for pi. We actually use a pi on our calculator. Okay, and I'll show you that when we get there. The area of a square, you can actually do one of 2 ways. The real thing is, I think you guys all know in a square, these would be the same. So say these are all 5s. The easy way to do it would be to just take 5 and square it. If you wanted to use the formula for a rectangle's area and go length times width and go 5 times 5, that would be the same thing. The area of a rectangle, I think you're comfortable with. It's just length times width. Area of a circle, you have to know the radius. So if they gave you the diameter, if you want to add this, if you don't know this, the radius would just be taking your diameter and dividing by 2. Now this last one, there's actually a couple different formulas that we will use this year to find the area of a triangle. And this is the most basic one. And what you would need to do is you need to know the base and you have to know the height that is perpendicular to the base. So height has to be perpendicular, okay? And then you would go 1/2 base times height. Now that is one way your triangle could look. Another way it could look is like this. And on this would be your base. Your height has to be perpendicular, so this would be your height. and you'd go 1/2 times base times height. The last way that you're gonna see today is you could have a triangle. That looks like this, where this is not perpendicular. And imagine this is straight across, okay? So this, I should draw this better. So let's do this. So this is our triangle, this is the base. So for you to be able to find the area of that, you need to know the perpendicular height. So what they would do is they would kind of put the perpendicular height somewhere there. And this would be the height that you have to use. Okay. And you'll notice we're going to be using Pythagorean theorem when we do that. So you'll see that today too. But when I'm finding the area of this triangle, I care about the base and I care about the perpendicular height. And then it's 1/2 base times height. So for your assignment, what it's going to look like is this. Some of these are easier than others. So this first one is a rectangle, and we have to find the perimeter or circumference. They're the same thing. They usually use perimeter when it's a polygon. They use circumference when it's a circle. So that's one thing we have to find, and then we have to find the area. Now, in a rectangle, one thing we can assume is that opposite sides are the same. So if this is 3.2, this is 3.2. If this is 2.1, this is 2.1. So our perimeter then would just be adding those four together. So that would just be 2.1 plus 2.1 plus 3.2 plus 3.2. And when you add that together, you get 4.2 plus 6.4, which would be 10.6, and that's centimeters. Okay, so I do want to see that work. Then for area of a rectangle is length times width. This could be my length, this could be my width, or base times height. How did they write it? Length times width. So that would be just 3.2 times 2.1. If I get my calculator, what were those two again? 3.2 times 2.1, thank you. And that would be 6.72. Now, area is going to have squared dimensions. So this is going to be centimeters squared. Perimeter and circumference are not squared. Area is going to be squared. Now we have a circle. And again, you'll have these formulas. So if you look at a circle, we're given the radius. So we'd use this. And then for the area, we're going to use this. Okay. So for the circumference, it's 2 times pi times the radius. So we go 2 times our pi key times 3. Now, on a graphing calculator, okay, your pi key is above this caret looking thing. Okay, so to get that, we would have to go 2 times. Pi we get by going second and then this caret. A lot of us call this an up arrow or a caret. And then times, what was the radius? 3, thank you. So that one we just round to 2 decimal places, so it'd be 18.85. And that is circumference, so it's normal units. Then when I go to the area formula, it's pi times your radius squared. So again, we'd use the pi key, and the radius on this is 3, and we'd square it, which by the way, I should show you where the pi key is on this, in case you use this one. And this one is actually just the 4th one down. You don't have to hit shift if you're using this calculator. Okay. So we are going to go pi times 3 squared. So I just do second up arrow times 3 and then the x squared key right there. Enter, and it would be 28.27. 28.27. And here your units are squared. And if I go down here, I have a triangle. And when I have that triangle, I again have to find 2 things. I have to find my perimeter and I have to find the area. So the perimeter in this is easy. We just have to add going around. So we're going to go 9.5 plus 10.2 plus 9.5. Which if I do 9.5 plus 10.2 plus 9.5, I get 29.2. And perimeter is just normal units. Okay. Now I have to find the area of the triangle. And again, if we look back here, this is our formula, 1/2 base times height. So if I go down here, my formula for this is 1/2 base times height. So I would look here, the base is going to be the bottom. So this is your base. Do you guys know which one of these we use as our height? The 8. And why do we use the 8? Because it is perpendicular, it forms a right angle. Very good. So what we would do there is we'd go, now I avoid fractions if I can, so I'd actually write this in as 0.5, my base is 10.2, and my height is 8. Okay, so if we go to our calculator, we can just go 0.5 times 10.2 times 8. And we get 40.8. Now this is area, so this would be square units. Here is another triangle. And again, when we do that, we want to find the perimeter and we want to find the area. And what you're finding the perimeter of is the shaded triangle. So do you guys get, you would add the 5, the 12, and the 16, okay, the sides of that yellow. So if I went 5 plus 12 plus 16, I believe that would be 33, and that would just be feet. Okay. When I go to find my area, it's 1/2, which we can think of as 0.5 base times height. So we're going to go 0.5. What do you guys think my base would be? 5. And what one would be my height? The 8 out here. So I only use the yellow base. That is just drawn there so that we can move it out to get that perpendicular. And if you went 0.5 times 5 times 8, you're going to get 20, and that would be feet squared. Okay. Now, if we go to this, what we are going to do here is we are going to first, well, I want to find the perimeter first. So to do that, I need to find C. So what we're going to do is we're going to use the Pythagorean theorem, which I showed you when we did distance formula. So with Pythagorean theorem, you have your two legs, which we call A and B, and the hypotenuse is across from the right angle. And remember, Pythagorean theorem is a squared plus b squared equals c squared, and c has to be the hypotenuse. So if I do a squared plus b squared equals c squared, my c is going to be across from the hypotenuse, which they actually already labeled c. And then my a and b are the legs. And it does not matter which leg you call A and which leg you call B. So I'm going to go 7 squared plus 7 squared equals c squared. Now you can punch this in. If you just went 7 squared plus 7 squared, that's going to give you 98. And then you would find the square root of that. If we do square root, you can go second x squared, and that'll give you the square root, 98. And now this one, if this is 89.9, what would you round that 89 up to? 90, right? Do you get it? Would be 9.90 really. So you could put 9. Oops. Right. So you could put 9.90 or just 9.9. That's what this is. Now I still need to find this perimeter, and I still need to find the area. So what I'm going to do first, I'm going to find the perimeter by adding around 7 plus 9.9. And that would give me 23.9 centimeters. Okay. Then I need to find the area. And the area is going to be 0.5 base times height. So it'd be 0.5. My base is 7. My height is 7. So this would be your base. This would be the height because it's perpendicular. Okay, so it'd be 0.5 times 7 times 7, which would be half of 49, which is what, 24.5? And that is area, so that's centimeters squared. So your assignment then is this right here. So yeah, with that whole thing, what I would do if you're somebody who works really fast, I would just bring your math book or bring homework from another class that you've done. Some days you have more work time than others, but like today, I'm guessing you're gonna finish early. And if you need to run and grab homework or your MacBook, you can.